I found the example I want to use. I have a handout that I give in my regular classes, confidence interval estimates. So if you're taking this as a class from me, you'll have this handout. And confidence interval examples. Problem 2. Let me read it to you. A random sample of 212 high school students in a particular town showed that 56 smoke on a regular basis. Find the 95% confidence interval estimating the population percentage for smokers at this high school. Alright, so we have, the particulars are this. We have a sample size of, 212 high school students. And the percentage that smoke at this high school, capital P is going to be percentage, 56 out of 212 smoke. And I did this calculation a minute ago. I think it's 26.4. Yes, it is. So I'm going to take the number of smokers divided by the number of students. That tells me that 26.4% of the students at this high school smoke. Now, for these examples on this handout, all the numbers are totally made up. So I don't even know if this is within the realm of reasonableness, but because I made the numbers up. But play along with me here. 26.4% is the point estimate for smokers at this high school. It would have to be a big high school. Okay, the one I went to down in Florida had 4,000 students, so a sample of 212 would just be a small portion of that high school. Okay, well, I'm supposed to find the 95% confidence interval, estimating the population percentage for smokers at this high school. So the big thing that's different about this problem over the previous few is that there's not a sample mean given, there's not a standard deviation given. And this because this is a different kind of data. The first two examples I did on this video were metric data. This data, however, is binomial or binary data. There's only two choices. Either the student smokes or he doesn't smoke. And with only two choices, it's called binary or binomial data. Sometimes it's called Bernoulli data. And so it requires a different calculation to estimate the confidence interval. So you might wonder, well, what is the population mean? What is well, we're trying to estimate the population percentage. What's the standard deviation? Well, it turns out the standard deviation can be calculated from binary data. I don't expect you to know the calculation, but it's the sample size times percentage times the complement of this percentage, which would be 73.6%. Subtract this from 100%. So if I multiplied 212 times 26.4 times 73.6. Oh, we also have to take the square root of that product. Take the square root of that product. Then we would have the standard deviation for this sample. So anyway, don't worry about that. It's built into the confidence interval formulas. So you don't have to worry about calculating the standard deviation. It's already done for you in the formulas. Well, so we have a different sort of data here, percentage data. Sometimes we call it proportional data. If you work with fractions or decimals, it would be proportion. This I'm going to state in terms of percentage, so it's percentage data. And the symbol for population percentage is capital Pi. So that stands for population percentage. So I'm going to change my Greek letter. We're going to be estimating capital Pi instead of Greek letter mu. Population percentage is what we're estimating from this little sample. Okay, well, it turns out because binary data has a little better, well, it has a very well-defined statistics and probability to it. And we can calculate the population standard deviation. Theoretically, we can. it turns out that we don't use the student's t-distribution in this case. For population problems, percentage problems that is, for percentage problems, we use the standard normal z-distribution on page 649. So I need z-scores, not t-scores. Something else for you to keep track of. Okay. Now, I have 95% confidence. 95% confidence is the level that we're shooting for in our estimation. Means alpha is 0.05. So what I need is the z-score associated with half of the alpha. In other words, again, it's a two-tailed test. We take the alpha type 1 error divided by 2. Those are these tails. And in this case, it would be the z-score based upon a probability of 0.025. Well, it takes a little longer to find a z-score using the chart on page 649. But if you look on page 648, there's a little tiny chart that works perfect for this situation. So if you look at this little short chart on page 648 and look for a probability of 0.025, and under it you'll see 1.96. So the z-score associated with this probability is 1.96. When you think about the empirical rule, middle 95% is 2 standard deviations. Well, that's kind of a rough estimate. The exact is more like 1.96 rather than 2. So 1.96 is the number we use for this problem. Okay, now in the textbook, I don't like the way they present this formula, so I'm going to make it a little more general. Let's see, where is that at? Page 249. So I'm going to kind of rewrite this confidence interval calculation. Here's the formula as I'm going to write it. The population percentage pi belongs to an interval of percentages, and it will be capital P minus the z-score based upon alpha over 2 times the square root of p parentheses 100 minus p all divided by n, comma, and then capital P plus the z-score alpha over 2 square root p 100 minus p over n, close bracket. So here's our confidence interval formula as I stated it. The textbook is sort of assuming you're always going to use 95% confidence, so they just put the number 1.96 there. They sort of cut to the chase. But if you wanted to change your confidence level, this is a little more, well, this is more broad. Whatever your confidence level is, you could need to calculate that z-score. It's not always 1.96, unless you always use 95% confidence. Okay, so there's the formula as I would write it. And you find out this book, when they use a capital P, they're talking about a percentage. When they use a small case p in this context, they're talking about a decimal. And so it's a little bit aggravating, because in chapter 7 there are 2 authors of the book. I think one wrote one chapter and one wrote the other. They're inconsistent. In chapter 7 they use small p instead of capital P. So we'll worry about that much later.